Suppose we start with the exponential equation x to the a equals x to the b. Take the log of both sides. This will give us a times log x equals b times log x. Log x is equal to log x, so these can cancel, and that's going to imply that a is equal to b. This is really useful, because what it implies is if we can write an exponential equation like this, since x is the same, it implies that a is equal to b. So here's the rule. If x to the a is equal to x to the b, a is equal to b. So if we have an equation x to the a equals x to the b, that tells us that we can also say a is equal to b. So we're going to look at a couple of examples. The question says, write each expression with base 2. First one they give us is 4 to the 6. Take a pair of brackets. 6 is our outside exponent. I'm going to write 4 as 2 to the exponent 2. Inside exponent times outside exponent tells us that this is going to be 2 to the exponent 12. Eight to the exponent 3. Could use the same technique. 2 to the exponent 3 will give me 8. 2 times 2 times 2. My outside exponent is 3. So I'm going to do inside times outside. This is going to give me 2 to the exponent 9. One over 8 to the exponent 2. They want the base to be 2. 2 to the 3 would give me 8. 2 to the negative 3 will put the 8 in the denominator. 2 to the negative 3 is the same as 1 over 8. Negative 3 times 2. 2 to the exponent negative 6. How do we write that with base 2? The base is 2. I need to know the exponent. Well, the definition of log is if I take the log of a number, it gives me the exponent that I need to raise the base of the log to get that number. So if I had log base 2 of 14, think about it. Log base 2 of 14 is going to give me the exponent that I need the base 2 to be raised to get 14. Also remember 2 times log 2, so if these two bases are the same, essentially you get 14, which is that. This is going to be key in the later few sections. Question number 2. Question number 2 says, write each expression with base 3. So I have 27 squared, and I can write 27 as 3 to the exponent 3. 3 times 3 times 3. Got inside exponent times outside exponent. Remember, the exponent of 3 there is 1, ninja 1. So if I bring the 3 to the top, it'll become 3 to the exponent negative 1. And then I've got my inside exponent times outside exponent, which will give me 3 to the exponent negative 4. I can write 10 as 3 to the exponent log 3 of 10. One over 2 is equal to 3 to the log base 3 of 1 over 2. Question number 4 says, write each expression as a single power of 4. So I've got 3 as my outside exponent. 16 is the same as 4 squared. And if that makes you uncomfortable, you can also see that the square root of 16 is 4. And then you have an outside exponent of 3. Well, what is 4? 4 is 4 to the exponent 1, ninja 1. That's going to be 4 to the exponent 3. Remember, the cube root means the exponent is 1 over 3. 16 is the same as 4 squared. It's going to be inside exponent 2 times 1 over 3. Remember, 2 times 1 over 3, there's an ninja 1. 2 times 1 is 2, 1 times 3 is 3. So this here is 2 to the exponent 6. That's what 64 is. The square root is 1 over 2. We've got a 3. We've got 128. So this 3, that fourth root is the 1 over 4, and I'm going to write 128. 128 is 2 to the exponent 7. This is going to give us 2 to the exponent 6 times 1 is 6. 6 divided by 2 is 3. This one, I've got 7 over 1 times 1 over 4. That's going to give me 7 over 4. And then I'm multiplying it by 3, which is really 3 over 1. 3 times 7 is 21. 4 times 1, 4. Now, I'm multiplying something with the same base. So I'm going to add the exponents. So I've got 3 over 1 plus 21 over 4. If I multiply this by 4 over 4, this becomes 12 over 4 plus 21 over 4. $33 over 4. Now, here's a little tip. I want this exponent to be 2, because that would give me 4. But if I'm going to multiply by 2, I need to divide out that same 2. So let's see that in slow motion. This number, where did the half come from? I want to cancel out that 2. But instead of cancelling it out, 2 squared is 4. 33 times 1 is 33. 4 times 2, 8. And I can use that same technique for D. D says radical 2 So I'm going to use the same strategy. I'm just going to work it out in terms of 2 and then transform the 2 to a 4. This is going to give me, this is 2 to the 1/2 times 8. This is 2 to the 1/3 times 4. 1 over 2 times 8 is 4. 1 over 3 times 4 is 4 over 3. When I add those two, I've got 2 to the 4 over 1 plus 4 over 3. This 4 over 1 is really 12 over 3. So when you add those, you're going to get 2 to the exponent 12 over 3 plus 4 over 3. Now, here's that little tip. I have 2 to the exponent 16 over 3. I want this to be squared. But if I'm going to put that 2 in there, I'm going to divide it out outside. This is 4. 2 divides into 16 8 times. So your final answer is 4 exponent 8 over 3. Finally, we're going to work on solving exponential equations. The main idea is to write both sides with the same base. I've got 2 and I've got 4, and I can write 4 as a power of 2. So 2 to the 4x equals. So there's my exponent x plus 3. And instead of 4, I've got 2 squared. So this 2 squared came from there. Two to the 4x equals 2 times x, 2 times 3, same base. I can equate the exponents. So 4x equals 2x plus 6. 4x minus 2x equals 6. 2x equals 6. X equals 3. Alright, 25 to the x minus 1 equals 5 to the 3x. So I can write 25 as 5 squared. This will give me 5. 2 times x, 2 times negative 1, since my bases are equal, I can now say 2x minus 2 equals 3x. Minus 2 equals 3x minus 2x. Minus 2 equals x. Alright, I'm going to write 9 as a power of 3. So I've got 3 to the w plus 1 equals 3 squared. Now that my bases are equal, I can say w plus 1 equals 2w minus 2. So 1 plus 2 equals 2w minus w. 1 plus 2 is 3. 2w minus w is w. Alright, I can write 36 as a power of 2. Six squared is 36. This is going to give me 6. 2 times 3m is 6m. 2 times negative 1 is negative 2. And just like in the other examples, my bases are equal. So I can say 6m minus 2 equals 2m plus 5. Six m minus 2m equals 5 plus 2. 6m minus 2m is 4m. 5 plus 2 is 7. M is equal to 7 over 4. Alright, 4 to the 3x equals 8 to the x minus 3. I'm going to write them both as the same base, which makes things a lot easier. I can write 4 as 2 to the exponent 2, and I can write 8 as 2 to the exponent 3. That's going to give me 2 to the exponent 6x equals 2 to the exponent 3x minus 9. Since the bases are the same, I can say 6x equals 3x minus 9. Six x minus 3x equals negative 9. 3x equals negative 9. I'm going to divide both sides by the coefficient of x. It's going to tell me that x is equal to negative 3. Alright, so what I'm going to do is I'm going to write both sides as base 3. 3 to the exponent 3 will give me 27. 3 to the exponent 2 will give me 9. 3 times x, 2 times 2x, 2 times negative 3. Since my bases are both 3, I can say 3x is equal to 4x minus 6. I'm going to bring the 6 over, it's going to become positive. 4x minus 3x, which is going to tell me that 6 is equal to x. Alright, I'm going to write both sides as base 5. Notice how I set it up. Make sure my exponents are correct first. Then I'm going to change my 125. 5 to the exponent 3 is 125. 5 to the exponent 2 is 25. 3 times 2y, 6y. 3 times negative 1. 2 times y. 2 times 4. Now, since my bases are both 5, I can equate the exponents, and I can say 6y minus 3 equals 2y plus 8. 6y minus 2y equals 8 plus 3. 6y minus 2y is 4y. 8 plus 3 is 11. I'm going to divide both sides by the coefficient of my variable. Y is equal to 11 over 4. Alright, I'm going to write both sides as a power of 2. First, of course, I'm going to make sure I've got my exponents correct. 32 is the same as 2 to the exponent 5. 16 is the same as 2 to the exponent 4. So now I've got 2 to the exponent 4 times 2k, which will give me 8k. 4 times negative 3. And I've got 2, 5k plus 15. Now that my exponents are both 2, I can write that 8k minus 12 is equal to 5k plus 15. So 8k minus 5k is equal to 15 plus 12. 8 minus 5, 15 plus 12. If I divide both sides by 3, k equals 9. Alright, so I'm going to start off I'm going to do multiple transformations here. First of all, keep in mind that the square root basically means 1 over 2. Alright, next, this basically means x times 1 over 2. Why? Because that's 1 over 2 times x, and there's a ninja 1 there. 1 times x is x, 1 times 2 is 2. Next thing I'm going to do is I'm going to keep that x over 2 outside. I'm going to write 8 as 2 to the 3. Now, this is the same as 3 over 1 times x over 2, which will give me 3x over 2. Alright, the 2's are equal, so we're going to set the exponents equal and solve for x. So I have 3x over 2 equals x minus 2. This is going to give me 3x over 2 . Alright, so I'm going to start off by writing this expression. 8 is the same as 2 cubed, and the square root is the same as 1 over 2. Again, 2 to the exponent 3 is the 8, and the 1 over 2 is the square root. Now, when I multiply these, it's 3 times 1 over 2 is 3 over 2, and 3 over 2 times x is 3 over 2x. So 3 times 1 over 2, 3 over 2, 3 over 2 times x, 3 over 2x. The exponents are the same, the bases are the same, beg your pardon, so we're going to set the exponents equal. So 3 over 2x is equal to x minus 2. This is the same as 3 over 2x minus x equals minus 2. Now remember, this is minus 1, so 3 over 2 minus 1 is going to give me 1/2 x. So I can multiply both sides by 2. That's going to give me x equals negative 4. So I can write 9 as 3 squared. I can write 27 as 2 cubed, and the square root of 27 is 2 cubed to the half. 2k, 2 times negative 1 is negative 2. Yes, sorry, this should be 3. Okay. Alright, let's try that again. Sorry for the whatever that is. Alright. 9 is the same as 3 squared. "27 is the same as 3 cubed, and the square root is the same as 1/2. So 3 cubed is the 27, this half is the square root. Okay, now this business is 3 times 1 over 2 times 2k. So the 3 came from the 27, the 1/2 came from the square root, and the 2k came from there. We can cancel here. That just gives me 3k. And now that my bases are the same, I can equate the exponents. "2k minus 2 equals 3k, minus 2 equals 3k minus 2k, minus 2 equals k."